Hello everyone, welcome to the Microcontroller and Embedded System lab. Today we shall discuss about program number 8, that is write a program to count the number of zeros and ones in two consecutive memory location. Okay, how this is done is we are considering two numbers, one is 0x3 and one is 0x2. The binary conversion of this is represented in 32-bit number. Okay, this is binary conversion of 0x03 and this is the binary conversion of 0x02. This is binary of 0x02. Now the program is written to count number of zeros present in both the memory location, total number of zeros and total number of ones present in these two numbers. Okay, here this is 32-bit number. Among 32-bit number, 2 are ones and 30 are zeros. Here only one is number of ones and remaining 31 are number of zeros. Therefore, total number of ones will be equal to 3 and total number of zeros will be equal to 61. Okay, but this will be stored in binary. Sorry, this will be stored in hexadecimal value. So 3D. The total number of zeros is equal to 3D and number of ones will be equal to 3. Okay. This will be the total number of zeros and this will be the total number of ones. Okay. How we will do this is using rotate operation. Okay, rotate right operation. Okay, we are using rotate right operation to count number of zeros and ones. Rotate right operation is as shown in the figure. How it is done is the LSB. Okay, LSB means if this is a binary number. Okay, here this will be the, that is least significant bit, and this 0 will be the MSB, that is most significant bit. In rotate operation, what will happen is this LSB will be copied to MSB and also to carry flag. After one time rotation, the result will be 1. Okay. This will be the result after one time rotation, and also carry flag will be equal to 1. Okay. Depending on the carry flag, we will count number of zeros and ones. For better, we shall go to the program. Okay. This is our program. Here we are initializing 3 registers. Okay, first register is used to count number of ones. Next, R2 register is used to count number of zeros, and R3 is telling how many data we are considering. Okay, here we are considering 2 data. One is 3 and one other one is 2. We can consider 3 data, 4 data. Okay, the program is asked to count the zeros and ones in 2 consecutive memory locations. So therefore we are considering 2 data. Next line we are adding address to R4. So address of the value holds 0x3 and 0x2. Address of these two memory location is added to register R4. Then we are loading R5 with 32 because in each and every number there are 32 bits. We have to check or we have to rotate the number 32 times, therefore we are loading 32 to R5. Then the value present at memory location R4 is loaded to R3. For example, if you are considering 03 first, the value will be stored at location R4. The value will be copied to R3. Then R rotated 1 bit and the same value will be stored in R3. If after rotation, if carry flag is high, that means carry flag is 1, then it will go to this loop where count of ones will be incremented by 1. If it is not high, that means carry flag is equal to 0, then our 0 counter or the register used to count 0 will be incremented by 1. Okay. After this condition is checked, either 0 counter is incremented or 1 counter is incremented depending upon this condition. Okay. After that, R5 will be decremented 1. Okay, we have to rotate 32 times, but after one rotation this has to be decremented. It is decremented and it is checked whether it is equal to 0. If it is equal to 0, then this will not be executed. Here the condition says that branch if not equal to loop 0. So if R5 is not equal to 0, then it will loop to loop 0 again. R3 will be rotated once again. It is checked with the carry flag. If carry flag is high, then R1 will be incremented. If carry flag is low, R2 will be incremented. This loop executes, loop 0 executes till R5 becomes 0. If R5 is equal to 0, then it will come to subtract R3 by 1. Okay, we are storing R3 the number of datas. Okay, once one data's zeros and ones are count, second data has to be considered. Therefore we are decrementing R3 by 1. It's checking for condition branch not equal to. If R3 is not 0, it will again move to loop 2. Again the second number also contains 32 bits, therefore R5 will be copied with the value 32 bits. Again it will repeat the same procedure. Okay, let us understand this by running the program. Debug. Okay. Now we shall execute step by step. After executing first, R1 will be copied with 0, that is not highlighted. Then R2 is copied with 0 and R3 is copied with 2, that is number of datas. Next, R4 will be loaded with a value, that is address of your number. Okay, you check for, type the address and check here. You can find 03 is stored in this address and 2 will be stored in next consecutive memory location. Okay, that is plus 4. After that, R5 is copied with 32. Okay, here this is decimal 32, which hexadecimal value is equal to decimal value is 32, which is equal to hexadecimal 20, which will be stored in R5. Okay, after that the content of R4 will be copied to R6. Execute and select. See, at memory location 0x6040, the value stored was 3, which will be copied to register R6. Then R6 will store the value after rotating one time. Okay, R6 is initially R6 was having the value 0x03, which will be rotated 1 and the resultant value will be stored in R6. So now here what we are doing, we have to check for carry flag. See, carry flag is equal to 1, therefore which register has to be increased? R1 has to be increased. Okay, observe R1 has increased by 1 bit. Okay, because carry flag was high. So here carry flag was high, it will go to label ones. Here R1 is incremented by 1. Next line, after that R5 will be decremented by 1. It was initially 32, that will be decremented, that equal to 31. That is it's showing hexadecimal 1F, which is equal to decimal 31. Again, this R6 will be rotated one more times and it will check for carry flag. Now observe, carry flag is equal to 1 again, therefore R1 will be incremented. For all the 32 bit it will check. Okay, after checking you can observe the value of R6. It goes on changing, and even the R5 value go on increasing. Now observe, R5 is equal to 0. That means we have checked all the 32 bits. Okay. Now after executing this, let us check the value of R1 and R2. R1 is equal to 0x2 and R2 is equal to 0x1e. That is, R1 is holding the value of number of ones and R2 is holding value of number of zeros. Okay, one. Observe, 0x03 has only 2 number of ones and remaining 30 are number of zeros. Okay, 1e is nothing but hexadecimal of 30. When e is equal to hexadecimal 30. Okay, okay, this is number of zeros and this is number of ones. Okay, this is only after executing one number. Okay. Then we shall continue. Observe, R3 has become 1. We are counting now the second number. Again, R5 is copied with the value 32. Then all the rotation, and it will check for one carry flag. If it is high, then one number of ones will be added with +1 and number of ones will be increased. If carry is low, then number of zeros will be increased. Again, the same procedure will be followed for the other number. Again, the RF, you can observe R5 goes on decreasing and there will be change in R1 and R2. After executing the complete program, we can observe that R1 value is 3, that is number of ones is equal to 3 and number of zeros is equal to 3D. Hexadecimal 3D is equal to decimal 61. That means 61 zeros and we have only 3 ones. already counted that first element has 2 number of ones and other 30 are number of zeros. In second number we have only one number of 1 and 31 number of zeros. So therefore the total number of zeros will be equal to 61 and total number of ones will be equal to 3. The result found here is total number